Good morning. Welcome to Pre-Calculus. This is Coach Jackson, and the first day of notes, we're going to be talking about functions. You have had experience with functions in other math classes. Um, Basically, the first 3 units of pre-calculus, we'll be doing a little bit of review and some new stuff added in. So remember that to have a function, you first have to have a relation. And a relation is a set of x and y values. X's are called the inputs, y's are called the output. So, a couple of definitions to begin with here. You can also know that the set of x values is known as the domain, and the set of y values is known as the range. So, we're going to be using these throughout the first unit. So, what is a function? A function is a relation where every x value has exactly one y value. In other words, the x's do not repeat. That's one easy way you can figure that out if it's a function or not. If you see the same x value twice or more, you know it's not going to be a function. Okay? Let's look at some examples. Here's a set of points, 1, 3, negative 5, 4, 7, 3. We want to name the domain. Well, the domain are the x values. The x values in this are 1, negative 5, and 7. You can write them in numerical order and put them in the brackets. Okay. What is the range? Well, the range is the y values, which is 3 and 4. You do not need to write the y values twice. If you see a number like 3 that's written twice, you only have to write it once. So the big question is this a function? Well, if we look at the x values, 1, negative 5, and 7, none of them repeat. Okay? None of them repeat. So this is a function. Every x has exactly one y. This next example is called mapping, where you group the x values in one circle or shape, and you group the y values together in another. And you draw arrows to represent the points that are related to each other. So, for example, we have a point 2, 1, we have 2, 5, and we have 4, 8. So mapping is another way to represent coordinates. So the question is this a function? Remember, you can't have x's repeat. In this case, 2 repeats. This is not a function. Another one, we have 4, 2, 6, 2, and 8, 4. The x's do not repeat, so this is a function. We can write functions as y being equal to a function of x, since x is the input. So sometimes you'll see y equals, sometimes you'll see f of x equals, and these two are the same thing. We use f of x because we're going to be plugging some numbers in and getting answers for x. Okay. So here's f of x equals x squared minus 4x. We want to find f of 3. Remember, we write it as f of x, so x equals 3. I'm going to plug in 3 wherever I see an x. So I'm going to plug in a 3 here, and I'm going to plug in a 3 here. And I'm going to do the math. So 3 squared minus 4 times 3 gives me a negative 3. So f of 3 equals negative 3. X is 3. The y value, which is the same as f of x, is negative 3. Okay. What if I plug in an a? Well, if I plug in an a wherever I see an x, it looks like this. A squared minus 4a. There's nothing else you can simplify. You leave that as your answer. What if I plug in x plus h wherever I see an x? Remember, it was x squared minus 4x. So I plugged in x plus h here, and I plugged in x plus h right there. Now I do the math. X plus h times x plus h, that's a binomial times a binomial. Negative 4 times x plus h, that's the distributive property. So x plus h all squared is x squared plus 2xh plus h squared. And negative 4 times x is negative 4x. Negative 4 times h is negative 4h. Look to simplify any common terms. This one does not simplify any further. Example number 2 is what we call a piecewise function, and you should have talked about those in Math 3. What makes them a piecewise function is for f of x equals x plus 1, you're only looking at x values that are greater than or equal to 0. For f of x equals negative x, you're looking at x values less than 0. So a piecewise function has more than one equation, and they have different domains. Well, how do we use that when evaluating? If I look at f of 2, I first have to check and see which domain does 2 fall into. Well, 2 is greater than or equal to 0. That's true. So I'm going to use x plus 1. We're going to use that top function and plug in 2. If I add 1 to 2, I get 3. So f of 2 equals 3. Well, what if I plug in negative 5? Well, let's look at it. Negative 5 falls into the second one because negative 5 is less than 0. So if I plug in negative 5 to that equation, the negative of a negative 5, double negatives become a positive. My answer is 5. So remember, with piecewise functions, you have to look at the domain of the x values. Here we want to find all the real values so that f of x equals 0. So in other words, we want to make these equations equal 0. We're going to replace f of x with 0. So let's do that. Now we have an equation. I want to solve for x. First thing you want to look to do is factor. I notice that both of my terms here have an x, so I can factor out an x. Excuse me. I know that x squared minus 16 is a perfect square binomial, so I can factor those into x plus 4, x minus 4. And if I take each one of those factors and set it equal to 0, x equals 0, x plus 4 equals 0, x minus 4 equals 0, and I solve, I get three answers: 0, -4, and +4. Next example is radical. Again, we make f of x equals 0, and I solve for x. I need to get rid of the radical. It's a square root, so I square both sides. And when I do that, 0 squared is 0. If I square this, the radical goes away, and I'm left with x squared minus 4. I can add 4 to both sides. And to get rid of the square, I can take the square root, and I get two answers. Remember, when you take the square root, when solving an equation, you get a positive and a negative. So this is +2 and -2 for my answer. Feel free to pause this video at any time during the notes session. If you need to catch up, if I'm going too fast, feel free to pause it. We need to look at how to find the domain of a function. There's three cases you have to be aware of. One is when you have a fraction. When we have a fraction, we want to set the denominator not equal to 0. Even roots, that's the square root, a fourth root, a sixth root. We want to make sure we set the inside greater than or equal to 0. Okay. Those are two most important. Anything else is, the domain is all real numbers. So we only have two that become a problem that we have to do a little math with. And we're going to look at some examples. We want to make sure we write our domain in what's called set notation. Okay? We write the range as numbers. Parentheses means the number's not included. Brackets means the number is included. And we put this symbol, which is union, in between each set. So I'll show you how to do that as we run through some examples. We want to find the domain of x cubed plus 3x plus 1. Well, number one, is it a fraction? No, it's not. Is there a radical, square root, fourth root, sixth root? No. Well, if that's the case, then it must be case number 3. It has to be all real numbers. Okay? How do I write all real numbers in set notation? Well, anytime you use infinity, that includes all the numbers. We want parentheses. So if I include all real numbers, I'm going from negative infinity to positive infinity. Example 2, what do you notice? It's a fraction. The rule says if it's a fraction, I have to set the denominator not equal to 0. If I solve this, I subtract 2. So x cannot equal -2. It can be any other number in the real number system, but it cannot be 2. So how do I write that? Well, I want to exclude -2. So I go from negative infinity to -2, but I don't include it, so I use parentheses. And then I'll go from -2 to infinity, but I don't want to include the -2, so I use a parenthesis. And I always use parentheses after or before an infinity symbol. Okay? Example 3, I see an even root. That means on the inside, I want it to set it equal to, greater than or equal to 0. So 5 minus x greater than or equal to 0. And I want to solve for it. So if I subtract 5, I get negative x greater than or equal to negative 5. Divide by negative 1. Well, what happens when you divide by negative 1? It's going to change the direction of that sign, and I'm going to have x is less than or equal to 5. Anytime I see the equal to symbol, I'm going to use brackets. So around this 5, I'm going to have a bracket all the way down to negative infinity, which I'm going to have a parenthesis. Okay, let's go back to number 4. It is a positive even root. So I take what's underneath the radical, make it greater than or equal to 0, and I solve for that. I'll have negative x squared greater than or equal to negative 4. I get rid of the negative. It changed the direction of my sign. And if I take the square root of both sides, how many answers will I get? Well, going back to previous math class, less than or equal to is and, greater than or equal to is an or. I'll have x is less than or equal to 2, and x is greater than or equal to negative 2. This is less than or equal to. I'm going to use the word and. When you see the word and, it's including every number in between your two answers. So I write it with brackets, negative 2 to 2. I'm including every number between negative 2 and 2 in my answer set. And we'll get a little practice with that also. Last thing we're going to look at, or next to last thing, is evaluating the difference quotient. This is known as the difference quotient. We're going to be plugging numbers in for x, or expressions in for x. Okay. They've told me that f of x equals negative 2x plus 4. I want to find the difference quotient for that. That means to do this part right here, I'm going to plug in x plus h where I see an x. For f of x, I'm going to plug in an x wherever I see an x. If I do that, that just leaves the same function I started with. So let's do the first step. I want to plug in x plus h wherever I see an x. If I plug in an x plus h here, I'll have negative 2 times x plus h. Still got my positive 4. I'll put that in brackets. And then I want to subtract, because this is a subtraction sign up here. And I subtract f of x. Well, f of x was just my function, negative 2x plus 4. So minus, in parentheses, negative 2x plus 4. All divided by h. Then I do the math. Simplify everything. I've got to distribute this negative 2. I'll get negative 2x. I'll get negative 2h. Still have my plus 4. Negative times negative 2x is a positive 2x. Negative times positive 4 is a negative 4. I should have some things that would cancel out. My negative 2x and my positive 2x cancel out. My positive 4 and my negative 4 cancel out. And my h cancels out. So what I should have left for this is a negative 2 for my answer. Please stay very organized when working these type problems, and you should be fine with it. Last thing, determine if a an equation represents y as a function of x. Here's the rule of thumb. If you see a y squared, it is not a function. If you see a y squared, it is not a function. So if we solve for y, this is what we'll get. Determine if that's a function. This is not a function. If x equals 0, then y equals 2, and also negative 2. So the x repeats. And if we were to graph this, this is what's known as a sideways parabola. It looks something like this. It fails the vertical line test. We have 2x values for every y. Okay. So if you see a y squared, it is not a function. All right, that's it for day one. Tomorrow we'll talk more about functions.